first. Let's keep talking about sequences.
Not serious.
Anyway, here we go. So, yesterday we were talking about these little guys and how they're separated, their numeric values or their terms separated by commas, not addition. Oh, sorry, it came up. Go away. And we just started saying like, oh, hey, remember there are these special ones, arithmetic and geometric. Like, yay! Anyway, so arithmetic, whatever you want to say. Remember, he's the more basic. He's the earlier math that you probably learned. He's the addition, subtraction, not the geometric multiplication and division. He has a common difference, not a common ratio. Does this sound a lot like pre-cal?
I think algebra 2.
Oh, that too. Okay, so pre-cal 2. We do have certain special formulas for arithmetic ones. Let me go and zoom in. But yesterday, what was the big thing that we reviewed? There's an implicit, recursive way of defining these sequences, not series. I did it for you. And there's also an explicit way. There's an nth term formula, but there's also a recursive, showing the jumpity jump is how I would put it, showing the pattern, showing the progression from one term to the next. Much more helpful for programming, much more difficult to come up with on your own. But for special ones, like arithmetic and geometric, there are these defined ones that technically you memorized once upon a time. And you could memorize again, or you could just understand. For instance, whenever we're trying to do a recursive formula for arithmetic, it's always going to be the nth term is the previous term. Remember this terminology? Nth term is the previous term plus the common difference, which could be a positive or it could be a negative. It could be a positive or it could be a negative. I feel like I was supposed to fill in something right there. There's so much space, but I have no idea what it is. The only thing I can think of is that, like, whenever you have recursive, you have to have a starting point. So if you guys look at your calculator, which we'll look at in just a second, you'll see like is it U? It's not A. I think it's U and D and W. And your Y equals, is it U and D and W? You have a U min or you have a U n min, and that would be your initial term that you're trying to know your starting point from. And then you have like a U of n that's letting you give some sort of formula for how to proceed, how to go forward. Yeah, it's good. So then, let's say you're given a sequence. Thank you. Not series. Because there are commas, not addition. Wow, all of you already? It's been like literally 5 minutes. Not serious. Thank you. A little late, but we're getting there. So let's say you're given this guy, okay? 1, 3 halves, 2, 5 halves, blah, 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 blah. Let's just make sure we're good. Okay, what's the common difference? D is equal to? 1 half. The 8th term is going to be A sub 8, and the calculator, it'd be U of 8. Is going to be 5. How'd you get there so fast, Lorenzo?
Adding them in.
But the problem is the 8th term can't be a 5 because the 8th term has to be an over 2 because the 8th term is an even term, and any even term is going to be a half, right? So not 5, 9. There you go. Does that make sense? Because it'd be 5 halves, 7 halves, 9 halves. So there are patterns. Just be careful. A recursive rule for the nth term would have to start with the first term, but then what would come next? A, well, careful. A to the n equals A to the n minus 1. Good. Okay, are we seeing how we're building this? But what's the hardest part of this entire thing? Letter D. Unless you have memorized some sort of formula to make for letter D, now we have to say, I need some sort of rule, some sort of, you can say A sub n, your calculator would put it more like function notation, A of n. Either one means the same thing. Or we're just talking about the nth term. But going straight to the nth term as a function of n. Give me the n, I'll give you the answer. This one says give me the n. Well, actually, no. Give me the previous term, I'll give you the next term. That's all that. This one says give me the n, I'll give you the answer. I need some sort of formula such that plugging in 1 gives me 1. Plugging in 2 gives me 3 halves. Plugging in 3 gives me 2. Plugging in 4 gives me. So let's see what's going on. I need a of 1 to equal 1. I need a of 2 to equal 3 over 2. A of 3 to equal 2. A of 4 to equal 5 over 2. Now we could come back and say something like, well, this is 4 over 2, and this is 2 over 2. We have 2 different variations. Lainey, give me yours first.
1 plus n all over 2.
Kevin, give me yours.
1 plus 1 half times n minus 1.
Who's right? They're both almost the same. What am I doing to see almost the same? Don't they both have an n over 2 component? This one has a 1 minus 1 half. That one, which would just be 1 half. This one's 1 half plus 1 half n, and this one's 1 plus 1 half n. So they are different. How can we check? Well, can't we just plug in 1? Plug in 1, we start at 3 halves, but we need to start at 1. Plugging in 1, we start at 1. This one's technically correct if we start at n equals 1. This one would be correct if we were starting at n equals 0. Do you guys see in your calculator how you can establish who n min is? You can have it start at 0, or you can have it start at 1. Remember how I talked about yesterday in physics, maybe sometimes at the beginning of a situation you would want the beginning variable to be 0 because time is 0 at the beginning? I mean, depending on how you measure time. But, or like in sigmas, once we get to series, we get to say where to start in that lower bound. We get to say like, hey, start with I equals 0 and go to whatever you want, or start with I equals 1, and so we can actually determine which one we start with, or the problem can tell us which one we're starting with. So in some ways they're both right, but this one, according to what I wrote, is the best answer because I wrote a of 1. I didn't write a of 0. Does that make sense? This one would work for a of 0. That one works for a of 1. Meaning the first term, not the 0th term. Okay. What else should we review? I think the next page has us actually talking about our calculator for just a second. Nope, not yet. That's the next page. That's the next page. It's coming. Okay, so we just talked about arithmetic. Let's talk about geometric. Geometric, what's different? Recursively, you're just multiplying by a common ratio, which means multiplying or dividing, right guys? But my question with multiplying or dividing, what would happen if my common ratio, whether it was growing or causing the sequence to grow, not series, or whether it was causing the sequence, not series, to shrink, aka whether the ratio is over 1 or less than 1, what would happen if my common ratio was negative? Bounce back. 1 second negative, the next second positive, the next second negative, the next second positive. Mathematically, calculus BC, we would say it would be alternating. That's going to be kind of important. Alternating. A negative ratio would cause it to be alternating. Oh, hey, like the one that we see down below. -3, +9, -27, +81. The only way to do that is to be multiplying by a negative. What's my common ratio in the one that you see? -3. That looks off. Sorry, any recursive rule, you should technically have an initial term. A sub 1 is equal to some sort of constant. I don't know what. For all r's, I don't want to say that. In general, we could say an r greater than 1 or less than -1 will cause it to grow. Will cause the absolute value of a sub n to grow. There we go, that's better. The absolute value of r is greater than 1, the absolute value of a sub n will grow. The absolute value of r is less than 1, and the absolute value of a sub n will shrink. I don't mind that. This is basically like completely disregarding the sign. Those kinds of r's will make these guys grow. These kinds of r's will make these guys shrink, but completely disregarding the sign, the positives and negatives, just looking at the actual numeric values. Oh, magnitude. Hey, physics, huh? Absolutely. Or pre-cal vectors, chapter 6. Anyway. The ninth term, remember notation, we're just reviewing a lot of notation also. Oh, as I put a sub 8, that's awkward. It would be the ninth term if I started at 8. Okay, but I'm starting at 1. So a sub 9 is equal to?
Negative 19,680.
How'd you get there? Just kept on. 3, negative 3. What was it, Kevin? Negative 19,000?
682.
But in just a second, we're going to talk about how could you have jumped straight there by thinking explicit rule. What would you have plugged 9 into to get this value and not have to have repeatedly multiplied by negative 3? Recursive rule, though, says start at the first term, which is negative 3. And by me saying a sub 1, I've established, right? We're starting with n equals 1, not starting with n equals 0. And then a sub n, how do recursive rules work? Yeah. This technically says times r, but wouldn't we normally put constants in the front? It's a little bit nice. Just notation. So remember, these subscripts, they're just kind of talking about placements, right? But we can be thinking, in some senses, of function notation. It can be kind of like a of n, even though it's a sub n, which is why we have a mode in our calculator with sequence. The independent variable is n, the dependent variable is n, or u, sorry, u, v, w. How could we have jumped to negative 19,683 in one jump instead of in 8 separate ones? 8 jumps? Why would we have done 8 jumps? Well, technically, we would have done 5 jumps. Not so much the 8 sub 8, but more the idea of jumping. How many fingers am I holding up? One. But if I had like a little ant on this one who was jumping from the tips of my fingers, from one tip of finger to another tip of finger, how many jumps would he have to take to get to the fifth? Just 4, right? Because he's already at this one. Just 1, 2. You have 5 fingers, but you have 4 spaces. Sure? So if you're starting at a first term, that's kind of like the nice way to always start any geometric or any arithmetic sequence.
Not series.
Is to start at the first term, because you always have him before you jump. Wait, jump. Well, how am I jumping? Aren't I Kevin, didn't you do times negative 3 times negative 3 times negative 3? How do we do repeated multiplication? So to get to the 9th from the first, we just need to take 8 jumps. But wait a minute, this is supposed to be a general formula. So 8 jumps would have gotten us straight to that answer that Kevin had to go jumpity jump jump to get. So couldn't we change this to be, instead of 8 in general, isn't it always going to be n minus 1? Now this one's super snazzy. This is technically the formula, true? But even though this is technically the formula, isn't there a property of exponents that would let me simplify this formula? What would the property of exponents tell me this could also be rewritten as? Because these are like bases. I wait and pause and think. Hold on. Can I truly just write negative 3 to the n? Does it work? Okay, because I'm able to actually rewrite this as to the 1. But what was I thinking of just for a split second? Doesn't this negative not get messed with a power? But this one does. True? But because I'm allowed to rewrite him as to the first power and him, okay, technically exponent rules like bases, it's fine. Reason being, yes, he's always going to be a negative, but he flips back and forth, which means multiplying will flip back and forth, so we're actually okay. But just for a split second, I was like, wait a minute. But no. Properties of exponents like bases, we can go ahead and remember exponents add. So what's n minus 1 plus 1? Or what's 1 plus n minus 1? Yeah. So this is the formula, but it can be simplified. maybe like derivatives, we can use a formula, but then we need to get those derivatives simplified to make it match. You might eventually be seeing expressions of nth terms that have been gotten from formulas and simplified, just having it rolling around in your brain. So, I know, we're still doing pre-cal, just having fun, reminding, remembering, thinking in a different way than we have in a long time. If that's true, okay, tell me about the question being asked. Ready, set, process, consider groups. Have a couple of minutes. How are you, Mrs. Pratt? You can go on. I want the first term, I want the common ratio, and I want an A sub n formula. You can probably, I don't know if this is going to be long or short. Go ahead, you can. You guys know what it's asking for, right? It's a puzzle. Some of your brains just see it and you're like, oh, that's it. Some of your brains have to think through what's really going on. Guys, I'm okay to erase secant cubed, right? We're good?
So basically you have to find a number, so you can multiply to the first term, and by that same number to the third term, second term. So like, yeah, so like it's right hand term. So 3010 times 10. What is the fifth term?
That is an arithmetic. What happens if you keep adding more? Yeah.
Oh, shoot. How would you go backwards? Yeah, so from the fourth term, right? By 10, it's the third term, the second term, first term.
Why is my shoes on I don't want to. So the common ratio is
I mean, that's the only thing.
You could say not a lot.
explicit.
Oh, I guess.
That's toxic. You're not a lot.
You guys agree with 3.01? Are we thinking scientific notation?
Yeah.
Are we thinking all the additional zeros that showed up with these multiplications and how our decimal place would have to keep moving to the left to go this direction? Multiplying goes forward, dividing goes backwards. So what are we missing? We have the common ratio. We have the first term. What are we missing is the a sub n. A sub n minus 1 times 10. Nope. I want the explicit rule. 3.01 times 10 to the... Now, pause. Do you see that this would be the exact same thing as 0.301 times 10 to the n? Isn't 10 to the n minus 1, isn't that 10 to the n all over 10, and this divided by 10 would just move it one more place? Yeah. So this one's kind of like with n starting at 1, this one's kind of like n starting at 0. Anyway, so is this one good? Yes. Is this one simpler? Yes. Uh-oh, why am I talking about simplified answers? Making it match, right? AP guys and all that jazz. Okay, so calculators. I had to get it out a little while ago. I just want to show you how the calculator can be used. It's not necessarily necessary, that's awkward. It's not super necessary for the AP, but remember sometimes you can use your calculators and they might ask you a question, and isn't it nice to know how to sometimes use your calculator to help you with an educated guess?
Yes.
Okay, so how could you maybe use your calculator for discovery purposes as we're getting used to sequences, not series, and series? I know, I beat you.
What's the point?
Because I was about to say series, and I thought it was weird. Yeah. Ooh, nice. But if we're graphing a sequence,
Not serious.
or if we're trying to deal with one, solve one, find the 100th term of one, etc., there are things that can be done. So you already have the SEQ mode. We've already talked about how the n-min, you can start with an initial term being labeled as a sub 0 or a sub 1. Usually for our purposes, at least right now, I think most of them are starting at 1. But anyway, we'll see a little bit of both depending on, well, not yet, not in chapter 9, more in chapter 9 OT. But when we've been talking about a sub n, the nth term, our calculator would call that u of n, using function notation to kind of be that subscript notation for the nth term. So either one is the nth term. So when R says u of n min, it's talking about like the a sub 0 or the a sub 1, the initial term. And then we can use the graph, although the graph is going to be kind of messy because it's just like I have a first and a second and a third and a fourth and a fifth, although that would be a really weird sequence. But I guess it would be possible. But if you're graphing, remember the graph is going to be discrete because in sequence mode, you just have a first and a second and a third. You don't have a 1.1 and a 1.3 and a 1.37692. Like there is no connection of a graph or of a function in this mode because it's just a first, second, third. It's a very discrete collection of values. Anyway, straight mathematics, that's interesting, but not for right now. So if you were trying to graph, for instance, this function, it's called a b sub n, just, I don't know, it doesn't have to be an a sub n, it can be some other constant or some other variable. But do you see how this is a recursive rule, right? Adding to, adding to, adding to, we have an initial term. Just making sure you guys know what or how you could show this. You could go ahead and put it in that SEQ mode. You could go ahead and change up some of the options. I don't really think most of this is even important. But when you do go over here, in this one, since it says b sub 1, I would want that 1 to be my n-min, my starting term, my first term. I would then be able to go ahead and plug into my u of n. You can plug in a recursive rule telling the program, the calculator in your, the computer in your calculator to say like, hey, to find this, go to the one before. So I can say the one before using function notation. Has anybody found the u though? We know where to find like x, the variable button. We know where to find n, that's the variable button. Where is there a little lowercase u on your calculator? 7. Second 7? Is that right?
Yeah.
Blue? Second 7? Or hey, there's a v also if you need check it. Another one. Isn't that second 8?
Yeah.
I don't know if there's a W. But there is. Perfect. Keep going. But you could say second 7 parenthesis, the variable button is now at n. We're in that final mode. Minus 1 plus 2, and you would be able to recursively, basically, have the calculator go to like the 100th term for you, and you wouldn't have to worry about it. You could go to your table, you could type in like, hey, let's go to the 100th. So that's kind of snazzy. You could also like graph it on in your graph. You have to arrange the windows, etc. I don't think there's a zoom. Is there a zoom sequence? I don't think there's a zoom SEQ. There's a zoom stat, but I don't think there's a zoom SEQ. So you might just have to like manually see what values you have and go from there. But anyway, if you notice, once again, it's a discrete graph because it's the first, second, third, fourth. The only time it gets really weird is if you have an alternating one with like a negative ratio and then you'd be bouncing back and forth. That's really awkward. That's really weird. So that's how to use your calculator to kind of play around. So then we're ending with, oh, we're good, 40 seconds, stop! Don't be like the algebra. Convergence of sequence. The most important time.
I did it at the
So fun
exact
that you
same
said it.
time.
That was the most important time because convergence of a sequence,
Not a series.
can be found like this. You just take the limit as n goes to infinity of the terms and see if they stabilize towards a constant. If they don't stabilize towards a constant, aka go to infinity, aka go to negative infinity, aka forever be confused, oscillating. We can make something funny about that. But anyway, coming back, then it would diverge. But if it does stabilize towards some constant, aka a horizontal asymptote, aka a limit to infinity, then it will converge. It meaning the sequence.
Not series.
Because we need 2 chapters to figure out convergence of series. Bye guys, see you later.
I want to eat my mashed potatoes.
Okay, that's fine. Okay, Tanya, I'll be in the
Chicken.
You want to get it now or you want to get it later?